My name is Matthias. I'm from the Helmholtz Center for Environment Research in Leipzig, and I want to talk about automatic tool generation for tool software systems and also about local community building beyond Galaxy users. So I am a one-person core facility, the bioinformatics service for our research center that uses Galaxy as one of its main instruments to get bioinformatics software to the users. And so the U of Z has a bit more than 1,000 researchers, and they have lots of needs. So they want to do amplicon analysis, metagenomics, mass spectrometry, proteomics. So there is only a few topics that we don't scratch at one or the other point. And of course, I only know little about all those topics. So I can't do everything, so I need a community. And that's what basically Galaxy helps me a lot with. So we have a local Galaxy instance, which is running since around 2017, which is connected to a local Slurm HPC with approximately 4,000 cores. And at the moment, we have approximately 100 users. I always see the whole center is potential users, so I'm not there yet. But I try to get more users. Actually, I had more users, so I'm probably one of the few instances that sometimes also loses users, because we are also a high throughput institute in terms of users, so also users leave the U of Z. And we have a few dozen power users that I try to heavily support with what they want to do, that they can spread the word in their departments and so on. So I'm doing a little bit of local propaganda for Galaxy, trying to convince everyone at our research center, and also doing training based on the Galaxy training network. Since a few years, our research data management team also pushes a little bit in this direction. So Ricardo is now part of the imaging community and pushes also this forward. And I was thinking to myself, who else is there? Who else at the U of Z can make use of Galaxy? And at some point, I thought we not only have users, but we also have software developers. So the U of Z also develops software packages that we want to make public. We want, or the software developers, want users. And I thought maybe Galaxy is also a good point for them getting their software used. So the arguments that I usually try to bring forward was, so what can a software developer get from Galaxy? So they get a graphical user environment. So software developers, so if they develop algorithms or R packages and things like that, they usually don't have the time to create a graphical user interface. And that's what they can get by using Galaxy. They can get easy deployment, such that everyone easily can use it without any IT knowledge. They get resources. They get integration with existing software, for instance, in workflows. And they have a platform for training material. And one point that I forgot here is that they get a whole lot of potential users. So the use Galaxy servers have thousands, 10,000s of users. So this are all potential users that then can easily use the software, and they get a community. More or less for free. The only thing that needs to be done is that Galaxy tool or tools need to be created for the software. So I was looking for funding, and happily we have locally a department for knowledge and technology transfer, which usually is focused for creating new companies with products and creating patents. But what they also do, they have limited funding for open source project. So I tried and got funded 2 student assistants who helped me in the first phase to create Galaxy tools for some tools that I already knew that exists. One is DeepFP-Learn, which does machine learning on chemical formula given in smiles. So we have now a Galaxy tool for this. This actually also was kind of auto-generated tool. So it's part of Planemo, where you can, if you have a Python tool using the ArcParse library, then you can automatically create a first iteration of a tool wrapper. So it helps a lot. Another one is multi-GSEA, which does multi-omics and gene set enrichment analysis. And for this, we have created a tool and a training. Another one is SAQC, which is an automated software for quality control of time series data. And at this first stage, we created only an executor for the so-called SAQ scripts, which I will tell you a little bit more about later. And the next one was a workflow, actually, the Phi toolkit, which does phage-host interaction analysis. So what you give it genomes, assembled genomes. So then you analyze hosts and contained phages in this bacterial host, and then you analyze the phages, and in the end you create a report. So I'm still struggling with this. The good news is that I just got it running on the EU. But I would like to have it in the long end in the IWC workflow repository. So I'm struggling a lot with the resource requirements. So as a proxy, I give you here the sizes of the reference data, and not only needs huge reference data, it also requires lots of resources, which probably will not run in GitHub CI. So that's a problem that I would like to work on in the near future. Okay, so current steps. What I actually want to talk about is that I got a second funding for larger tool suites. So this was just the beginning, small tools with a decent number of parameters. And now I was trying to get Galaxy tools for 2 bigger software projects originating at the U of Z. So the problem with this is, so you have a tool suite consisting of dozens of executables, or you have a tool suite consisting of hundreds of modules with loads of parameters. And you would need months to create a tool wrapper or many tool wrappers for this. And while you have finished, the tool developers already created the next version, and then you start from scratch. So this won't work. So I always thought that for such cases, an automatic way to generate tools and tool tests could help here to have a sustainable life cycle of such tools. It also can help with consistency. So often it turns out that if you apply a consistent method that generates one language describing a tool into another one, you discover inconsistencies. And if you report this back upstream, this can also improve the upstream software, which is often really welcome feedback that the developers actually are looking for. So as maybe a previous example where I was involved a little bit in is OpenMS, also hundreds of tools, which we now for a few years generate automatically. We just need to find the time to push the button again. I was focusing in this project on 2 softwares from the U of Z. One is OpenGeosis and the other one SAQC, a system for automated quality control for time series data. And I think both applications also fit gaps for the Galaxy ecosystem or tool ecosystem. So what is OpenGeosis? I don't know the details, so I just asked the developers for an advertisement slide, and that's what I got. So OpenGeosys provides numerical methods for the simulation of hydromechanical chemical processes in porous and fractured media. So you see, I have no idea. And you can apply it if you're interested in deep geological repositories, geothermal energy, and groundwater systems, or if you are a country and you look where to deposit your radioactive waste, like Germany wants to do, you could use it as a scientific reference code, for instance. So OpenGeosys consists of 78 command line applications that we want to create Galaxy tools for. So it's mainly one big one and many other ones that are supporting. So the other one is SAQC, which is a framework to quality control time series data. So the problem that we have at the U of Z is that we have many experiments running with thousands of sensors that are somewhere around in the field, and they get millions of data points. And often the sensors break, or just for a period of time report wrong data. Some things go wrong all the time. And this needs to be quality checked and maybe also corrected. And for this, SAQC provides 65 methods in 17 modules. So it's actually Python software to analyze, process, and annotate such time series data. So you can resample data, interpolate, smooth data. You can check for outliers, breaks, or check for constants like minimum and maximum. And you can also do more advanced quality control patterns. So you have two ways to interact at the moment with SAQC. So it has a Python API and it has config files. So you see an example here. It's super simple tab separated values, where you have a variable that you want to apply something on, and then some function from one of the modules. And then you basically can configure in its config files a whole kind of pipeline that does the QC on your data, and you get output data and output flags and some visualizations of your time series data with colorful annotation where something might have gone wrong or something has been corrected. So what have we done? So on the left, you basically see one of the functions, the Python functions of SAQC. And as you see, the developers did quite a good job in terms of annotating their software. So they have type annotation for all the parameters, and they have quite a good help system. So what we basically do is we pass the type annotation of the Python functions and translate it to Galaxy parameters. So there is an integer parameter to this function, so that this gets an integer parameter of the Galaxy tool, and so on and so forth. And we also pass the help and generate help for the Galaxy tool automatically. So a few things were missing there. So for instance, the integer parameters could have minimum and maximum. So this is a feedback that we gave to the developers. So they added this. So now we can, in the next iteration, create Galaxy tools with minimum and maximum for tool parameters. And then there were a few parameters that have now even more improved type annotations using Pydantic. That helps us even more to get more better tools. So how does this look in Galaxy? Let's see if this works. Just video. So what we generated for SAQC is basically a repeat in the Galaxy tool. So you can add a method. So this is start. I need to press play another time. So you can choose one of the modules. Then you choose the method that you want to use. Then you select the values that you want to select. And then you can add further parts to your pipeline. So the tool then in the background creates the config file and then just executes via SAQC. So how do I now get back to the talk? Let's see. So a similar thing we did for OGS. So OGS is command line applications written in C++, and they use a library called TCLAP, I never heard of it before, to create their command line interface. So they do something like, okay, you have a command line argument, replace or --r with some help. This seems to be a switch arg, so kind of a Boolean. And so we took this information and also created Galaxy tool from this. This works quite well. So the biggest problem here is that there are many string parameters, and a string parameter can be a string, it can be a file, it can be a directory. So we somehow needed to distinguish this. So the developers have this now properly annotated, at least in the help, in a parsable way. And from this, we now create a Galaxy tool. 2 times play again. Yeah, you all know. That's just it's just a Galaxy tool. It kind of works. Proof of concept. So what is the state of this? The first version of the SAQC tool is now available on Use Galaxy EU. Improved versions are on the way using this improved type annotation. OGS is hopefully coming soon, so we have it nearly finished. So as a summary, I often would like to have the actual software developers of the underlying software of our Galaxy tools more involved in the creation of the Galaxy tools. So this would be super. So here we have, I hope, a good example. So the developers seem to enjoy the experience and hope to get new users. Let's see. And yeah, thank you for your attention.
An awesome job, and I mean, amazing that you are a one-man core facility, and you have the time to do Galaxy, and you have the time to do grants and all that stuff. So I mean, that's very impressive. I guess I have one question. What do you think about the macros in the automatic generation process? Are you generating macros, or are you just saying that there's no point because everything's auto-generated anyway?
So you mean for repeating parameters?
Yeah, right.
We don't do this at the moment.
Makes sense to me. I've seen auto-generated stuff with macros, but that's so complicated.
Yeah, I think for the more complicated tool parameters, for some of the more complex, we might use it. So where you need input text inputs with some regex validators, and if those repeat really often, yeah, maybe. But auto-generated tools, we could run an external program that detects the same parameter and then just creates parameters from this or macros.
I mean, I guess those macros help in manual maintenance, but if you're not doing
yeah.
Anyway.
Yeah.
Yeah. You showed this example with the tools that have large reference data and need probably a lot of memory that doesn't really work in GitHub. There are many people that make tools to know this and pay. You said you want to do something in this direction?
I hope so. Yes.
But like, what is your idea?
One idea would be to run the tests on a real Galaxy, not in the CI.
But it's part of IOC as well.
Yeah, for the tools, it's, I think, more complicated because you would need to install the tool. Maybe the user-provided tools that Marius just introduced could be a way in this direction. But for workflows, it's closer. It feels closer. Let's see how far we get with this. So with Planemo, we already can run tests against an instance. The question is only if we can trigger this from CI, let's say, of IWC, that we can directly run on the use Galaxy servers our workflow tests.
So it's really like a showstopper if you cannot make the
original
tool developers making small test data.
Yeah, there's already 2 tools in here which are on IUC, which are not tested, which is GTDB TK and CheckM, which just need too much resources to be testable.
GTDB, they made a smaller one, I asked them.
Yeah, but it still doesn't run on my computer. So it won't run on CI.
You want to answer that, Matthias?
Yeah. I mean, I guess we could also stub out some data, which, I mean, what's your idea on that? Like, if we could, like, see if we can replace certain types of import data if we run it in CI. I guess Nextdoor people love that. They have language to actually stub out things. Like you say, I received this string and this is a test case, and then you use that data instead of like the full reference. But I guess it doesn't really help if the software itself cannot possibly work with smaller data. And the other way to address it is potentially making all those tools that currently use reference data accept the directory and use like our directory data type. But again, it only works if you can actually use smaller data.
Yeah. I can only agree.
You see.
Okay. This reminds me a bit ArcParse2 tool that Elena developed. And I was wondering if there is a common space where all people that do this type of automation could put all the tools together, or at least document what they did, so it could be useful for other tool developers.
Yes, thanks for the question. So the successor of ArcParse2 tool is now incorporated in Planemo. I forgot the subcommand, but it's documented in the Planemo docs. Yes, and please use it and report bugs. We can fix them, or we can try.